Hey kiddos, it's Mr. G again. So I had some good comments about being able to hear the audio and using a mic and stuff, and zooming in. So thank you for all the helpful comments. So we're just going to do thermal stability. So the thermal stability appears to be the ability of a compound to resist decomposition when heated. Do you remember in Chem 20 when you decomposed malachite and it broke down into its different molecules? So when you heated it, it decomposed. Okay, so they'll ask which of the following compounds are more thermally stable. So we'll look at example 1. We're going to compare calcium oxide and calcium hydroxide. Which of those two compounds is more thermally stable? Okay, so let's look at the work here. How do we do this? So to do thermal stability, you have to look at your molar enthalpies of formation. So let's look those up. Let's look up calcium oxide. Calcium oxide, right there, is negative 634.19. But negative 634.19 is its enthalpy of formation. So let's write that down. Calcium oxide, its delta F formation, HM, is negative 634.9 kilojoules per mole. Okay? And then comparing calcium hydroxide, its delta FHM is negative 985.2 kilojoules per mole. Okay, well that's the formations. According to the definition, thermal stability, it's about the ability to resist decomposition when heated. So decomposition, what do you do to the formation? You got to flip it. Okay, so let's flip them. And when you flip them, you got to flip the signs. So it's delta DHM, the decomposition. You just flip the sign. So it's positive 634.9 kilojoules per mole. And let's look at the calcium hydroxide is positive 985.2 kilojoules per mole. Okay, so which of these two numbers is a bigger number? Positive 634 or positive 985? Positive 985 is a bigger number. It's a bigger positive number. So which is harder to break down? It's the calcium hydroxide. So which of these two compounds is more thermally stable? This is more thermally stable. Okay, let's look at the second example. The second example was ethane or ethene. Okay, C2H4 and C2H2, ethane and ethine. Ethene and ethine. Okay, so you do the same thing. Let's do the same thing. C2H2, its delta FHM is positive, so this is endothermic, 227.4 kilojoules per mole. C2H4 gas, ethene, so that's ethine, this is ethene. Its delta FHM is positive 52.4 kilojoules per mole. Okay, so we got to flip those to decompositions now because again, thermal stability is the resist decomposition. So delta DHM is negative 227.4 kilojoules per mole. And this is negative 52.4 kilojoules per mole. And again, whether it's endo or exothermic, the idea is the same. Pick the bigger number. Now, both of these are negative numbers. Which would you rather have in your bank? Negative $52 and negative 227. Clearly, I'd rather have negative 52. Negative 52 is a bigger number. Again, that is the, right, bigger number. This is more thermally stable compound. So calcium hydroxide at 985 in the previous example was the bigger of the two numbers, and C2H4 52.4 is the more thermally stable compound. So there you go, kiddos. There's thermal stability. It might be like one multiple choice question on, well, the diploma if we get one. But moving forward, now you understand thermal stability.